All right, we're on section 5.4, logarithmic functions and models. So first, what are logarithmic functions? Well, we talked when we on the last section about exponential functions, right? There's the graph of exponential functions. There's several different ones, and remember we said these are one-to-one, or we try to put horizontal lines. They only cross at one place on the graph of a exponential function. So these have inverses. So these are the inverses. The logarithmic functions are the inverses of exponential functions. So let's look at one exponential function, f of x equals 10 to the x. And if we think about some some values of x, not all of them, right, but a few of them, like -2, -1, 0, 1, and 2. And if we plug those in place of x, well, when we plug in the -2, it's 10 to the -2. Whatever that is, that's not simplified. So if we simplify it, we could write this as 1 over 100 or 0.01, right? Or 1 over 100. Either one, right? We plug in the -1, 10 to the -1 is 0.1 or 1/10. 1/10 or 0.1. Either one. All right. 10 to the 0 is 1. 10 to the first is 10, right? Notice that's not simplified. It's 10. And 10 to the second, right, would be 100. Okay. Now, if I think about the inverse function, how would that table look? Well, remember these values are just going to be flipped around, right? Okay, so my first input for x would be 0.01 or 100th, 0.01. And my output, f inverse of 0.01, will be -2. Okay? My input for the second will be 0.1. And my output would be -1, right? Now, we don't want to just be able to do that, to see these numbers and flip them around, because when we work these, we're not going to have tables like these. So what we want to do is think about it this way. 10 to the what power is 0.01? -2, right? Because that's how we got it. 10 to that power is 0.01. And 10 to that power is 1/10 or 0.1. And 10 to that power is 1. And 10 to that power is 10. All right, so so it's better we think of it that way. 10 to what power is 0.1? Well, -1. 10 to what power is 1? 0. 10 to what power is 10? The first power. And 10 to what power is 100? The second power. Notice I could keep going like that. All right, so that's one example, and we'll do this one in class, all together in class, for the exponential function f of x equals 2 to the x power. All right. These inverses have special names. So the inverse is called a logarithm with base 10. And why with base 10? Because that was the base on the exponential. Okay? So whatever the base was on the exponential, that's also the base on the logarithmic function. Okay? Base 10 is called a common logarithm. All right. And it's written this way. So we think of it as f inverse of x, but it's written log of x. We don't write f inverse of x. Okay? We don't write that. We just write this part, log of x. So like for this one, 0.01, we would write log of 0.01, and that would be -2, right? We would write it this way. Log of 0.01 is -2. Log of 1 is 0, the exponent. Notice that the answer is the exponent, right? Log of 100 would be whatever the exponent was, 2. Okay? So notice log of x is an exponent, right? That means the answer is an exponent, or the output is an exponent. And you can always ask yourself the question, 10 to what power is that x? So if we do some examples here, log of 10, we ask ourselves 10 to what power is 10? And that's the answer that we get, 1. 10 to what power is 100? 2. 10 to what power is 1/10? -1. And then 10 to what power is the square root of 1,000? So this one's tricky. That means we're going to learn something new. So 1,000 is 10 to the third. Okay, so we can think of this as log of 10 to the third, but then it's not just 10 to the third, it's the square root. And how do we write the square root? Well, this is the new thing you're learning. You put the 3 over 2. Okay? So whatever the power of the 10 is, over 2. Okay? And then 10 to what power is 10 to the 3 halves? Well, 10 to the 3 halves power is 10 to the 3 halves. Yeah? So notice we can now also do square roots of powers at least of 10, right? All right. Let's take a look at, in general, logarithmic functions, because remember there's exponential functions, there's many, right? It's not just base 10, it's base 2, and if you remember all these other ones, right? A bunch of different bases that we can have. Yeah. All right. So in general, the function is of the form f of x equals log base a of x. Remember, again, we don't write f of x. It is f of x, or whatever name you want to give it. But we just write log base a of x. Notice up here, the a is not written. That means when the a is not written, log base a, it's base 10. Okay? X has to be greater than 0, right? That number has to be greater than 0, the input. Or that's the domain, right? A has to be greater than 0 and a is not equal to 1. And these are the same exactly as the exponential functions. A has to be greater than 0 and a equal to 1. What about this x greater than 0? Well, remember on the exponentials, the range was the whole graph was above 0, right? Remember y equals 0 is a horizontal asymptote. So the range for these is 0. Greater than 0, I'm sorry, from 0 up, not including 0. So the domain for these is 0 and up, not including 0. Okay? All right. Let's do a problem here. So find the domain of log of x plus 5. So remember, the input has to be greater than 0. So we would tell ourselves x plus 5 has to be greater than 0. So x has to be greater than negative 5 if I just subtract 5. All right. I can write it this way, right? Or I can write it in interval notation, right, from negative 5 to infinity. All right, let's go a little further and notice we're going to use these, so we need to learn how to use them. Okay, so let's look in general for logarithms with base a. So log base a of x equals k is true if and only if a to the k equals x. Notice a is the base, k is the exponent, x is the output when you apply a to the k power. Okay. And if it's base 10, well, we would write it this way. Log of x equals k is true if and only if the base 10, notice it's unwritten, to the k power equals x. Okay? And, we have a new one, base e. So that's a special base. You remember e? Except we don't write log base e, we write ln. So when you see ln, it's base e. So e to the k has to be equal to x in order for ln of x. Ln of x to be k, right? E to the k has to equal x. Yeah? All right. What does that mean? What does all that mean, right? Because it sounds like just information. Really what it means is that we can write this as this. We can rewrite it in that form, right? So, for example, log base 2 of x equals 3 can be rewritten 2 to the third equals x, right? Notice where I'm looking at 2 to the third equals x, and then just write it. Right? Log of x equals 3 can be rewritten 10, the base, to the third equals x. Right? That's what its use is, right? ln of x equals 3 can be rewritten e to the third equals x. And vice versa. That means e to the third equals x, you can write it as ln of x equals 3. 10 to the third equals x, you can rewrite it as log of x equals 3. This is called the logarithmic form, and this is called the exponential form for all of these, right? Logarithmic form, exponential form. All right, let's do some of these. Okay, so let's find log base 2 of 8. So remember, we have to ask ourselves 2 to what power equals 8, right? And you can guess, right? I like to use a little helpful little mechanism here. I say the answer is k. I tell myself that. And then I rewrite this as 2 to the k has to equal 8. And that just helps me so I can see better what I'm looking for, right? I'm looking for that exponent. Whatever k has to be to give me 8, k has to be 3. Okay? I don't have to say k equals 3 because there was no k to begin with, but I can say k equals 3 because I put a k there. Okay? All right, let's try the second one. log base 2 of 1/8. So, and I'm going to say that would be k. So that means 2 to the k equals 1/8. You remember 2 to the third equals 8. How do we make it 1/8? We'll just make k a negative, right? K has to be negative 3. So 2 to the negative 3 would be 1 over 2 to the third, and that's 1 over 8. And let's do one more. Let's do letter D, and we'll leave the other ones for you. So log base 5 of 5 to the third equals k. And so 5 to the k has to equal 5 to the third. So k must equal, that's right, 3. Yeah. We got to put a little box around this one. That's our answer. All right, and we'll leave the other ones for you. All right. We'll continue in the next video by looking at the graphs of exponentials and their inverses, logarithms. And we know the relationship already, but we're going to take it from there on the next video.